All right, so on 226, impact of mining. So I had originally planned to do this cookie mining lab today to show kind of the process of mining, what the logistics, all the stuff that goes into it. And then I thought, I need to do this other thing. So we've got this computer assignment we're going to work on today. Basically, you're going to go in and you're going to look at, compare different watersheds. It's a simulation. And you're going to look at how different watersheds with different types of development, how they let water either soak in or water runs off. And so I thought that was good. And we talked so much about soil and water, how it's important to have good soil. And we're getting into the effects of urbanization, which is what's on tomorrow's agenda. And so I thought that would be better placed. And we're starting energy next week. So hopefully, what's the date? Friday should be our test on Unit 5. Tomorrow and Wednesday, we'll finish up notes. This is probably the biggest unit out of all the units this year. I mean, in terms of just amount of content. So you guys, hopefully y'all been studying over the break, which I know you haven't. But if I were y'all, I would not wait till Thursday or Wednesday and start studying. So I would get your review on, make sure you understand the concepts we've talked about, so you're not behind. Anyway, next week we start energy. Energy has to do with coal, oil, natural gas, all the different types of energy. And I thought, well, we'll already be talking about coal then, so I'll push the cookies back to next week. So we'll do cookie mining next week one day, and all will be well with the world, and that'll be okay. But that's why we're not doing it today. Antonise, I know that's why the only reason you returned. Them's the breaks. All right, let's see here. As easy access to minerals are depleted, what are minerals? Reagan? All right, who knows what minerals are? Mineral.
They are mined.
They are mined. What else?
They can be like, I don't know if
They come from the natural.
Okay. Here we go. Yes, there are different characteristics. So according to the Google, there's 5 characteristics. Y'all can write any of these down that you want to. They're naturally occurring. They're inorganic, meaning they don't have carbon. They are solid. They have a specific chemical composition, and they have an ordered internal structure. Some could be a specific type of element. It could be a thing with a chemical compound, but they have a specific structure to them, naturally occurring, and we use them usually for some type of resource, something that we need. Okay, so as easy access minerals are depleted. So in this day and age, the last 100, 200 years or so, we have really figured out how to access minerals in the earth. The easy to access minerals are found where?
underground.
What?
Right.
Where are the easy to access minerals?
On the surface.
Thank you, Damar. Yeah, they're pretty close to the surface. They're easy to get to. They're not floating in the air. I mean, they are under the ground a little bit, but close to the surface. So, as they become depleted, more ores are mined. What is an ore? Glad you asked. 226. Ores. Read that for us, Reagan. Redeem yourself.
Ores are concentrated accumulations of minerals from which economically valuable materials can be extracted. Ores are typically characterized by the presence of valuable metals, but accumulations of other valuable materials such as salt or sand can also be considered ores.
Okay, so let me give you an example. Well, if you look at the bottom of 226, the constituents of the Earth's crust, oxygen, silicon. Now, we get into the ones we know we use stuff for. Aluminum, iron, magnesium, calcium, and a bunch of other stuff. What do we use aluminum for? What? Cans. What else? Aluminum oil?
Foil. She said
Foil. You know, it's funny she said that. And we don't really have a good representative class since DeMar's the only guy in here. But every class today, like a girl has said aluminum foil and a guy has yelled out tin cans.
Tin can.
So, Andrea, you broke the chain there. I don't know if there's any overt gender discrimination going on among you people, but I don't like it. Men can use tinfoil as well. So anyway, especially on those hats to attract the aliens and stuff. Whatever. Obviously, you know more about this than I do. So anyway, aluminum. Aluminum does not come out of the ground like we see it. I don't have it. Well, there's aluminum here. Aluminum does not come out of the ground like this. Okay, aluminum in the ground looks like what? Yeah, it looks like dirt. Okay. Later on, we get to the waste section. We're going to go back and we're going to look at recycling a lot, and we're going to talk about how, like aluminum cans, you've already got aluminum. So to make more aluminum cans from those, all you have to do is what? Melt them down and stamp them out, make more aluminum cans. Pretty easy. It does require a good bit of energy to melt them, but it's nothing compared to taking the ore out of the ground, melting it. Basically, you're taking it looks like dirt. Like if you dug some dirt up out here, it would probably look about the same. I've seen it before. It's about the same. It just has aluminum ions like scattered throughout the dirt. The ore is called what? Good. It's the last word on page 226. That's bauxite, but close enough. So bauxite is where the ore that aluminum is found in. And so basically what they do is they take that bauxite, big scoops of dirt, and they dump it and they melt it. And they put these electrodes in there, and the electrodes down in there, somehow, I forget the science part of it, they attract the aluminum ions out of the solution. And so the aluminum ions get attracted to it, it pulls it out, they get rid of the rest of it. And so that's how they get aluminum. And then they use those aluminum plates where the ions gravitated toward, they use those to stamp out and roll and make whatever kind of aluminum they're making. Tinfoil, cans, whatever, Ford pickup trucks, and the rest. So anyway, aluminum has got some pretty cool properties because aluminum does not
burn.
bless you. Rust. Good. I see you've got some experience with this. So aluminum doesn't rust. It's also not magnetic, which is kind of weird. I'm sure Mr. Bolton can tell you why, but I don't really care. Anyway, it takes 20 times more energy to get aluminum from bauxite, the ore, than it does recycled cans. And you'll notice at the top of page 227 here, they've got a list of global reserves remaining and U.S. reserves remaining of each one of these elements or metals. Aluminum there's a lot of global reserves. We don't have much. You notice there's a bunch of ones that we don't have any of. Where do we get those resources from then? Overseas. We get them from other locations, other countries. And what that means is we're really dependent upon those other countries for getting those resources. We've got quite a few of some things, lead, copper, iron. I'm sure we could tear down half the rest of Birmingham and get plenty of what? Birmingham used to be known as the Steel City, but
I was right.
you were right. James Spann, if you ever hear him talk about weather, he's like, we're here high atop, what's the mountain? Red Mountain, good. Yeah, they've got a bunch of TV stations atop Red Mountain. And it's Red Mountain because
It's red.
it's got iron ore in it. Good, thank you. And so they cut a bunch of that iron ore out to make steel. Good job, Andrea. Thank you. So, very good. So anyway, but even still, no pun intended, it's much easier to take steel that you already have, like out of all old cars and stuff, and recycle that and just melt it down again than it is to take iron ore out of the side of a mountain, have to melt it and get the iron out of it that way. It requires much, much more energy. And you'll notice here, we don't have an indefinite supply of any of these, even globally. So the problem is resources. We have a limited amount. And if we use them and we throw all that junk throw all the stuff when we're done with it in the landfill, then what's going to happen when we run out of those resources?
Uh-oh.
We're going to be out of it. Somebody's going to be digging back through a landfill is what it looks like, and that's probably going to not be very productive in finding any of these metals. So that's an issue that we have to think about. We have to do a better job of recycling and replacing stuff. Otherwise, we're going to, somebody in the future is going to run out of things that they need to make products that we use quite often every day. All right. So anyway, let's get back to the notes. More difficult ores are mined. So once the easily accessed ones are done, we have to get more difficult ones. Where would they be more difficultly found? Farther underground. Good. If you look on 227 here, let me give you an example. A lot of coal early on was strip mined, meaning they strip away all the vegetation and stuff on top, trees, dirt, whatever. They pull it out of the way, and then the coal that's close to the surface, they dig it up, and then we use it to burn and create energy. Once most of the easily accessed surface coal was gone, they had to start doing what? Digging in the mountains. Well, most of it's not mountaintops because that's usually not where coal is found, although sometimes it is. But most of the time, it's found like in seams that go into the side of a mountain or hill. And so, or even like out in Brookwood, there's a lot of coal. There's some mines out there. I don't know if the mines are still active or not because they've stopped using as much coal for Alabama Power. Does anybody know anybody who works at the mine? Yeah?
Well, my friend's dad does.
Is it still going? They're still using it?
I think so.
I know their Alabama Power is not using as much, so I'm curious if they're producing as much out there, if they've got people laid off. I think a lot of people got laid off at one point. But anyway, imagine this subsurface structure here where you have to go down an elevator shaft, you have to dig seams. It's also much more dangerous. In the late 90s or early 2000s, there was an explosion or a collapse out at the Brookwood mine. I think also in Birmingham they had one at one point during that time frame. So back when I was growing up, when coal production was getting really going and was really high, like you'd hear about these mine collapses. And so that's another issue, not only cost, safety, all those are problems associated with coal mining. And also, what do you almost always find around coal and oil that's dangerous?
Soot. Or like.
Well, it's sooty anyway, but what do you find? Why did they send birds down into the coal mines?
Gas.
Gas. What gas? What gas is oftentimes found around oil and coal?
CO2.
What? Methane. So if you carry your little DeMar's bebopping down through the mine with his kerosene lantern and he runs into a little pocket of methane, what's going to happen?
He's gonna catch on fire.
Yeah, he's going to go boom. So that's also a big issue there, okay? So anyway, there's a lot of danger, a lot of problems associated with mining. More cost, more energy, more pollution to access those deeper resources. And so that's an issue. And as long as we keep using resources, we're going to have to keep digging up stuff. But keep in mind, there is a finite amount of resources, especially ones that are fairly easy to get to. Okay, next thing. Environmental surface mining. Removes organic material overburden to access materials underneath. In the surface mine or strip mine that you see right there on 227, they've stripped away all the vegetation. What's the environmental problem there? You destroyed a habitat, yes. Now, when mining was done on strip mines historically, what did they do? Back into the day.
Light on fire.
What were they lighting on fire? I don't know either. What do you think they did? The miners. You think they put it back like they found it? Do you think they just left it and went on the next one? What?
Probably just left it.
Probably just left it, went on the next one.
I didn't know what you were talking about.
And historically, that's what happened. So in 1977, turn to page 229, the U.S. passed a law, and they said if you hateful people are going to keep doing this and ruining the land and not putting it back like you found it or as close as you could, back to like you found it, then we're going to make you. Read that second paragraph on the right side of 229 for us, Simona.
What am I reading?
Second paragraph on the right side of 229. The surface. Right side at the top, 229.
The surface mining control.
Go to Mars, use camera shy.
The surface mining control and
Reclamation Act.
Reclamation Act of 1977 regulates surface mining of coal and the surface effects of subsurface coal mining. The act mandates that land by
B.
Oh.
Some of y'all need to stop doing drugs on these long breaks y'all have because y'all can't afford to lose any more brain cells. I'm just throwing that out there as a generalized warning. Go.
Is it minimally?
Minimally?
I overthink things. That's why I keep doing this. I overthink. Anyways, minimally disturbed during the mining process and reclaimed, whatever, after mining is completed.
Okay, so basically what that said is, if you surface mine and you wipe away the vegetation and you get at some resource underneath that, then you are responsible for putting that soil and dirt and stuff back and then replanting it and trying to get it back as close as you got it, as close as it was to before when you mined it, which you would expect would be the normal thing to do. Like for a person who's at the store and they carry their stuff out to put their shopping cart back where it goes, or at least in one of those little things. You know what I'm talking about, Jacayla? You ever run into people who just leave their cart in the middle of nowhere?
Oh, in the middle of a parking spot? That's the worst.
I heard that.
Somebody rolled one of our bugs to the McDonald's parking lot.
Wait, what?
I heard that the pub is in Northport.
Oh, I understand that.
Anyway, so yeah, it's called doing what's right. And so they had to pass a law and put that in place in order to make people do what's right, or you get a big fine and who knows what else. Hopefully like a public stockade or something might be more effective, but...
So they cut down the trees, or would they just take them out of the ground and like hold them until they were done?
I'm sure if it was like a forested area, they probably would log it first and get money from the trees and then come in and clear everything off. And then the responsibility would be for them to move as much topsoil back in as they could, because the problem on a lot of these, and I've seen this like up where I grew up, you can tell where a lot of these mines were because it's fairly open land and there's not much growing there, which is not very characteristic of where I grew up. It's mostly forested. And so you can see it's very poor soil because they didn't put a lot of that dirt back and nothing will grow there. And so that's the issue. What you ideally would want, get as much topsoil as you could back on there, and then either plant it in grass and let it just recover on its own after something's holding the soil in place. Or a lot of people will plant pine trees because they grow really well, and then they can use those for growing tree farms, basically. So something, but you're holding the soil in place. You're utilizing that area. You're not just letting it go to waste, essentially. Okay. So those are the environmental impacts associated with surface mining. So that's a big issue we have. Mining waste include soil, rocks, slag, tailings. Those rocks, slag, and tailings are just things that are left over. Because when you mine coal, I'm going to coal because we do this a lot around here, and this is one of the things that's mined a lot throughout the world for energy. You get a lot of rock out in the process. So it's not all like just coal in there. You've got to get a lot of shell or slate out that comes out with it that's found around it. I would love to go dig through one of these, they call them dumps, where they basically like they're digging down like the elevator shaft, or they're digging, trying to find a seam. And all the shell and stuff that they have, they just like dump it in these big piles. I really wanted to go through the one out in Brookwood, but I called them up and they wouldn't let me. I think they were afraid I'd get hurt on it. But why would I want to rubble through the shell that's out of a coal mine? The rock stuff.
Maybe some funky stuff in there.
How did the coal form? From?
Would there be like some,
Fossils.
Yeah.
Yeah. So that formed from plants and animals long ago. And so a lot of the impressions, you can find a lot of impressions of plants and animals in those rocks. So it's really a good place to go looking for fossils if you can get in there. I got a student, actually, a former student who works, I think he still works out there at Brookwood. Maybe I can get him to get us some fossils for class. Who doesn't like a good fossil for Christmas? Antonice, do you? Sure. Okay, then. All right, we'll get you one, Andrea, since you can appreciate it. All right, soil, make sure you put the soil back in place. The biggest problem there would be erosion, because if you disturb all that soil, you just leave it, then it's going to erode and wash into the streams and rivers. And so you want to get that back in place and plant something to hold it. All right, coal mining can destroy habitats, contaminate groundwater, surface water. That's a big issue. All up and down the Black Warrior River, there are old coal mines where they were just abandoned, and there's a lot of like acids and stuff that leak out of there because coal has a lot of sulfur in it. So that can affect the water. There's coal ash that's left over from where they burn the coal in power plants, like right on the river. They have these huge coal ash ponds that are like 600 acres, huge, where they put all the ash that's left over after they burn the coal. The problem is the coal, that ash and stuff has a lot of like mercury and lead and other heavy metals. So like the Black Warrior River Keeper and people like that watch out for the river, they're worried that a lot of those metals leach in or seep into the river, which would be a problem for us downstream. The power companies doesn't seem like they're too worried about it, but a lot of companies are only worried about their bottom line, so I don't know. They say it's safe, but if they said it wasn't safe, then that would be a big financial burden upon them. So that's I don't know. We'll see. Release PM. PM stands for particulate matter. You don't need to know this. We're going to talk more about particulate matter when we get into air pollution. But anytime you see that PM, that's usually what that's referring to. As you burn or coal is mined and released, like little particles and stuff get in the air, and then if you breathe them in, it's harmful to you, especially in the coal mining and the coal burning process. Or if you work in the coal mines, what do they get a lot that's bad for them? Black lung. Thank you. Maybe pneumonia too, Sarah. Maybe, but black lung results from inhaling all that coal dust, and it's just as it says, darkens the lungs. Similar to what you would see in someone who smoked for a significant amount of time. And methane, we talked about that. The more coal mined, the more is subsurface mined, which is more expensive, hence the price increase. And I really think that's the reason why Alabama Power has went away from coal mining, because it's a bigger pollutant, so there's more stuff they have to do so that it's not harmful to the environment. And because you have to get down in the ground so far to mine it out, it's starting to cost more than it used to. And so now it's really cheaper for them. They've started burning a lot of natural gas. I think that's where about 40% of our energy comes from now, and I think coal's down to maybe 25, 30%, somewhere in there. Where back in the day, like when I started teaching 20 years, how long have I been here? 18 years ago, coal accounted for about 55, 60% of our electricity. So it's changed quite a bit over the years, especially recently. All right, so here's what you're going to do. You're going to get your computers. You people at home, y'all know the assignment.